Hello, math humans. We are going to do 1.1b today. We're going to be talking about scatter plots and regression analysis. You're going to need to make sure you have your grapher handy because we are going to walk through a lengthy process on your calculator. Our objectives today are that we're going to review scatter plots and then use our glorious graphers to do those scatter plots and then find the line of best fit and predict outcomes. So if we go back and review a scatter plot, it's a way of representing two different sets of data. Okay, so it might look like here's my axes, and then I would have a title, and both would include units because that's always relevant. A graph without numbers is irrelevant. It's just a pretty picture. And then I would have some random data points, and then I would have a line of best fit. This is the line of best fit that goes through the data points, maybe not hitting all of the data points, but it's trying to show a model, and then the model is always the line of best fit, and in our calculator it's going to be the regression line that we use to make predictions, because it doesn't do us any good to have data to just look at it unless I can predict an outcome. Okay? One of the other words that you're going to hear when we talk about scatter plots is about correlation. Sorry, I was having a brain fart on how to spell that. And correlation talks about how is the data related. So a positive correlation would be like the one I've drawn here, and it shows that the data seems to have a positive slope trending upwards. Okay, so this would be an upward trend in the data. Okay, and then if I had a negative correlation, if we sketch that little guy over here, maybe my data looks like that, and here is my line of regression. So a negative would be a downward trend in the data. And then a fun one is no correlation, so that's what I call a scatter pattern. And so maybe this is what my data looks like, and there's no apparent pattern, and so that would be none, and then there is no apparent pattern. Okay, so those are the different things that we're talking about. In our calculators, the correlation is going to be represented by R, and it's called the correlation coefficient, and that is equal to R. Sometimes in your grapher it's going to show up as R squared, and then if it doesn't tell us what R is, then we just take the square root of R squared, and that gives us R. When we're talking about lines of best fit and we're looking for an R, we want R to be as close to 1.0 as possible. That means that if my R was 1, that the model would reflect 100% of the data points. So depending on the process, our goal would be to get as close to that as possible. So it might be that my R is 0.887, and that means that the model would reflect 88.7% of the data points. A line of best fit is just that. It's a line of best fit. It's not necessarily going to go through every single data point. If it did, that would be a correlation of 1. But oftentimes it doesn't. So we try to find a model that gives us the highest R value. All right. So for us, for this year, in Big Kid Math, we will never do this process by hand. We are always going to do it in our graphers, because the goal is to be able to find a model, which is the equation, and then be able to use that model to predict. So this is a beginning part of the process. We will not be doing this part by hand. So we are going to do a process that's called regression analysis. Okay, and we're going to walk through an example as we learn this, but basically what regression is going to do is I'm going to enter my data, and then I want to look at it. And what I mean by that is I want to look at the shape of the data. Does my data look like, you can't see that one, does my data look like a line? Does it maybe look like a parabola? Sometimes data doesn't have to look like a line. It can look like other curves. It could even be sinusoidal, which means that it looks like a sine curve. So what we're going to do now is we're going to walk through an example, and so you're going to need to make sure that you have your graphers handy. So I'm going to write out the example. It's a little bit long, but it's helpful if you have this written down so that we know how to manage the information that's been given. So anthropologists, I hate spelling those words. Whew, that's a lot of vowels. Use a model that relates femur length, so the length of your thigh bone, to height. So based on the length of my femur, they can predict how tall I'm going to be. The model allows an anthropologist to determine the height of an individual when only a partial skeleton is found. And that partial skeleton has to include the femur. So anthropologists, though they are not mathematicians, can use math to help them predict how tall a person was. So we have a couple of tasks. A, we're going to find a linear model. Oftentimes in regression problems, they will tell you what type of model to use, so you need to make sure that you read the words. And then we are going to justify the model mathematically, and that means that we are going to talk about the correlation coefficient because that is the mathematical justification for the model. And then our last task is we are going to predict the height of a human with a femur length, out of room, with a femur length of 58 centimeters, okay? All right, so now what we're going to do is I'm going to give you a set of data, and then we're going to start the process of regression. So in our table of data, the first is our femur length. And again, I would recommend that you pause as you need to make sure that you get this written down so you know that where all of the values come from as we try to walk through this example. And here is our height in centimeters. And then I'm going to write down your data points. So I have 50.1, 178.5, 48.3, 173.6, and then I have 45.2 and 164.8, and I have 44.7 and 163.6, 44.5, 168.3, 42.7, and 165. Running out of room. Only two more. 39.5 and 155.4. And then I have 38 and 155.8. All right, so this is all of our data that the anthropologists are going to use and we're going to use to try to develop a model. So this is a little bit of a tedious process, and I want you to make sure that you write down each step. So the first thing that we're going to do is we are going to clear the lists in our grapher. So I'm going to write down the step, and then I'm going to show it to you on your calculator. So this is second memory, and then 4 and enter. Okay, so then I'm going to do that. So I bring in my handy dandy grapher. Ooh, that's a wicked glare. Maybe I can put it right there. Okay, so then what I'm going to do is I'm going to go to the memory button. Okay, you can't see it. It's hard to get everything in. This is the memory up above the plus, so I'm going to go second memory. Now you need to see this part. Option number 4 is clear lists, and so that means that it's taking any data that's in my calculator and it's wiping it out so I can start with a clean slate. The next thing that we're going to do, I'll write it over here, maybe that'll help, is I need to turn on my scatter plots. So I'm going to turn on the scatter plots. Okay, and so I'm going to do second, and then I'm going to hit my stat plot button, and then I'm going to turn plot 1 on. There's lots of different plots. We'll see that when we get there. And then I'm going to do, look at what the calculator tells me. We'll talk about the X list, and we'll talk about the Y list, and then we're going to talk about the default. Okay. So these are our calculator steps. This is what we're going to see when we get there. So if I put my handy dandy grapher right here, I'm going to do second stat plot, and notice that all of them right now are turned off. You only want one turned on, so I'm going to go to the first one and I hit on. This little guy right here is a scatter plot. The view is really crappy because I can't get it close enough for you to see the writing and the calculator, but this is going to be like a line graph. I can do bar graphs, I can do box and whisker plots, so I can do lots of different things. The X list, this is my independent variable. The default on your calculator is L1. The Y would be the dependent variable, and in this case the default is L2. You can change what the marks look like, you could change the color, but at this point we don't care. Okay, I would just leave it as the defaults are set up. So then I'm going to hit, make sure I hit on again, and then I'm going to do quit. Okay. The next thing that we need to do, I'll write it over here so you can see, is we need to enter our data. So at this point, we've cleared memory, we've turned on the scatter plots. Now we're going to enter our data. Okay, and I'm going to try to keep that where you can see both. And these steps are, we're going to do stat, edit, and then we're going to enter our data. Now for me, when I do it, I always do my L1 first, and then I do all of the L2s. It is super critical that you get your data in correctly. If you don't, your model's going to be bad. So I'm going to quit. So I'm going to do stat, edit, and notice it goes right to L2. I'm going to put it in L1. This is my independent variable. The femur length is what I'm considering the independent variable. I can't change the length of your leg. That's not my job. Okay, so I'm going to enter all of my data. So make sure you take the time to do these steps because it is a long process. 42.7, 39, and 38. All right, and you have to check because if your data's wrong, everything's going to be wrong. So I have 50.1, 48.3, 45.2, 44.7, 44.5, 42.7, 39.5, and 38. Now I'm going to enter the corresponding Y values. 173.6, 164.8, 163.6, 165, and 155. All right, and then I'm going to do the same thing. I'm going to go back and make sure I didn't screw anything up because if I do, my data's going to be bad. 165, and I think we're good. The next step, step number 4, scoot it up just a little bit now so you can see the steps more than you can see the data, okay, because you'll have that on your paper. Now we're going to look at the data. It's important to know what the data looks like. So to do that, I'm going to do a zoom 9, which is a zoom statistics. Okay, so I'm going to do zoom 9. All right, and if you look at the data, it appears that it's a linear thing. They told us to find a linear model, so it looks like it's pretty linear. So I would assume that it's linear. You don't have to write that down. It just helps my poor little pea brain. Okay? So now what we want to do is we want to find the line of best fit, and our grapher is going to call it a regression line. So now what we want to do is our calculator operations are going to be stat, calculate. We're going to choose linear regression. Oops, I forgot the A, because our model looks like a line. Okay, so I'm going to go stat, calculate, and I'm going to choose option number 4 for a line. There's all different types of regression. I could do quadratic, cubic, quartic, which means it's to the 4th degree, natural logarithmic regression. This one you don't want to choose. I could do exponential, I could do power, I could do sinusoidal. Holy cow, there's a lot to choose from. But we want to choose a line because it looks like a line. And I'm going to hit enter. Okay. My calculator is asking, where is L1, where is L2? The frequency list I kind of don't care about. This one is ultra cool. Store regression equation. So I'm going to write those steps down. I'm going to do second, and then I'm going to do F4, and I'm going to tell it Y1. Okay? Oops, you can't see that. My bad. Let me scoot that up so you can see it. This is just a shortcut. You can do this different ways, and if your calculator is an older version, I can walk you through how to do that as well. So I'm going to go down to my store. I'm going to do alpha F4 I lied. This is alpha. And notice my little equations pop up, so I'm going to hit Y1, and then I'm going to go down to calculate, and I'm going to hit enter. At this point, you need to write down the equation. Okay, so it is imperative that you write down the equation. Y is equal to AX plus B is the same thing as Y equals MX plus B. You have to write the equation in this format. So my regression equation is Y is equal to, I'll put mine here so you can see my equation. And remember, I'm rounding to the third decimal. It's 1.880x plus 82.659. And it tells me R, and I'm going to write that down, 0.961. If your R is not turned on, I will show you how to do that in a moment. Okay? All right. So now what we're going to do, and I need to go to a different sheet of paper. So now step 6 is we are going to graph our line. Okay? So now I'm going to go to my Y equals. There's the equation. Don't mess with it. Don't truncate it. Don't do anything else. And I'm going to say graph. So now my grapher is just graphing my handy dandy line. Woohoo! All right. So now what I want to do is make predictions. The one thing that becomes difficult is that this is a set viewing window. When I do zoom 9, it's going to zoom on my data. Oftentimes I need to see more data than what is showing, so I'm going to do a zoom 3 enter, and I'm going to zoom out. So I'm doing a zoom 3 enter, okay, and that allows me to see more. So now as I make predictions, they said, what did they say they wanted us to do? They wanted us to predict, I don't remember. Let me look back and see. Predict the height of somebody who's 58 centimeters. So I want to do F of 58 centimeters. This is already in, so I'm going to do second, calculate, value, and I'm going to enter that 58. So second, calculate, value, I'm telling it that the x value is 58, and it's telling me the y value is right here, okay? My computer just locked up that day. There we go. So it's telling me that f of 58 centimeters is equal to 191.713 centimeters. Remember, I wrote down units and I predicted. So I think that we've met all of the criteria, okay? So before we finish for today, we're almost done. Let me show how to turn your R on in case it's not. So I'm going to go second catalog, and then I'm going to scroll down to the R's. Actually, I lied, it's to the C's. Keep going, coordinates. Oh, maybe it is R. I lied. It's right there, diagnostics. So I want to make sure that my diagnostics, second quit. So if I used to be in nothing, so I'm going to go back down and turn my diagnostics on. Okay, and I'll write that down so you have it. Go calculator. And I could search alphabetically, but for me, by the time I do that, then I'm good. So notice now my diagnostics are on, and then if you went back and recalculated, it would turn your correlation coefficient on. So my diagnostics are on, and I did that by second catalog. You only have to do that once, unless for some reason you reset your calculator, which I highly do not recommend that you do. But if you have issues, let me help you with your grapher. But this should, once you do it once, you never should have to do it again. I highly recommend that you go through and you take these steps that I gave you. I gave you 7 steps, and write those down on an index card. So write your steps on an index card. And then that way, when we walk through an example, when you come to class, you have it in a very concise form and in your own language. I would recommend that you walk back through this example, because on a test, I will expect that you can do this process by yourself. All right, my dears, that's it for today. See you soon.